sklearn, model selection, train test split. Description. This function is used to split data into training and testing sets, enabling the evaluation of machine learning models. The split is performed randomly, with the ability to specify the desired ratio of data for each set. Inputs. X. This is the input dataset containing features, represented as a 2D array NumPy array or pandas data frame. Y. This is the output or target variable, represented as a 1D array NumPy array or pandas series, corresponding to the features in X. Outputs. X. Train, the training set of features, ready to be used for model training. X. Test, the testing set of features, used for evaluating the performance of the trained model. Y. Train, the target values corresponding to X. Train, used for training the model. Y. Test, the target values corresponding to X. Test, used for evaluating the model's predictions. Steps. Randomly shuffles the input data. Splits the shuffled data into two sets based on the specified test size proportion. Returns the split sets X-train, X-test, Y-train, Y-test. Metrics. Not directly related to the function, but the split data allows evaluation of model performance using metrics like accuracy, precision, recall, F1 score, etc. Visualization plots. Not directly related to the function, but the split data can be visualized using plots like scatter plots, histograms, etc. To understand the distribution of data in training and testing sets. Fine-tune parameters. Test size. This parameter controls the proportion of data allocated to the testing set. It can be a float between 0 and 1, e.g., 0.2 for 20 testing data, or an integer specifying the absolute number of samples. Random state. This parameter provides control over the random shuffling of the data, ensuring reproducibility of the split. If an integer is provided, the same random split will be generated across multiple executions. Shuffle. This parameter determines if the data should be shuffled before splitting. Setting it to false may be useful if the data is already ordered, and maintaining that order is important for analysis. Uncertainty methods. Not directly applicable to this function, as it deals with data splitting, not model predictions. Challenges and fixes. Challenge 1. Imbalanced data. If the original data has a skewed class distribution, the split might result in imbalanced training and testing sets, potentially leading to biased model evaluation. Sample use case that resulted in challenge 1. A dataset with 90 positive samples and 10 negative samples, split using train test split with default parameters, could result in a training set with an even more skewed distribution, affecting model learning and evaluation. Fixes to challenge 1. Use stratified sampling. Stratify parameter in train test split. This ensures that the proportion of classes in each set matches the original data distribution. Oversampling and desampling techniques. These methods balance the class distribution by replicating minority class samples, oversampling, or removing majority class samples in desampling to create more balanced training sets. Challenge 2. Data leakage. If features used in the testing set are also present in the training set, the model might be unfairly influenced, leading to optimistic performance evaluation. Sample use case that resulted in challenge 2. Using features like customer IDs, which are unique to each customer, for both training and testing sets could lead to data leakage. Fixes to challenge 2. Ensure that the features used in training and testing sets are distinct, avoiding any leakage of information. Use proper techniques like cross-validation to ensure robust model evaluation and prevent overfitting.